Hello, students. So in this section, we're going to continue talking about the applications of trig functions. Previously, we saw how in real life, we can use trigonometry to measure the lengths that are not possible to measure by hand or manually. You cannot measure them. For example, the height of a really tall tower. Um, if you're looking, for example, if you're sitting on the top of a lighthouse and you're looking at a boat in the sea, you know how far the boat is from or you don't know how far the boat is from the base of the tower or the lighthouse, but you can figure out the angle that you are looking down, the angle of depression from where you are looking down at the boat, and you know the height of the lighthouse, then you can figure out how far it is, how far the boat is from the base of that lighthouse. Even if your angle is not very exact, you can get a good approximation by just using the trigonometry, by just using these two measurements, the angle and one of the sides. So today we're going to talk about the how we can actually find the angles sometimes. So just like before, we knew we had to know an angle and a side. Here we have to know at least two of the sides in order to figure out an angle. So we're again going to use the same trigonometry, the sine, cosine, and tangent ratios here. So let's look at this simple example of a right triangle in which we're given one of the two of the sides, the adjacent side for this angle and the hypotenuse. So we will figure out which of these three trig ratios, the sine, cosine, and tangent, are we going to use. We're keeping it simple, even though we do know the secant, cosecant, and cotangent also, but we're keeping it simple since on your calculators also you have sine, cosine, and tangent. So in this case, we are going to use cosine. So we will say cosine of this angle is equal to 9/12. Again, I want to emphasize in this video also that it is important that you put them in the right place. Like if you have adjacent side is 9, hypotenuse is 12, it has to be 9/12. You can't just put them in any order. Okay, so what's in the numerator has to be in the numerator. What should be in the denominator has to be in the denominator. So here I'm going to do the cosine inverse in order to get rid of this cosine. I just kind of tell students, you know how you do the inverse operation when you're solving. So it's kind of like doing the inverse operation. So cosine and cosine inverse cancel. And here you have cosine inverse of 9/12. You could simplify that, or you could just put it in the calculator and calculator can still give you the answer. So we're going to do cosine inverse, which is second cosine, because right above cosine, you will see cosine inverse. And usually you're given the directions or the rounding instructions. Usually we ask students to round the angles to the nearest degree. So if you do have to round it to the nearest degree, it will be 41 degrees. To the nearest tenth, it would have been 41.4. Okay, so let's look at the second problem here. It says, suppose you drive 0.6 miles on a road so that the vertical distance changes from 0 to 150 feet. What is the angle of elevation of the road? So you are driving 0.6 miles when you drove. The vertical height that you gained is 150 feet. Now notice here that the units are not same. One is in feet, the other is in miles. So pay very close attention because if you will use it as it is, your answer will be completely off. So make sure that you put them into the same unit of measurement. It doesn't matter whether you convert miles into feet or feet into miles. I'm going to just convert miles into feet. And I know that 1 mile has 5,280 feet. So just multiply 0.6 by 5,280. I got 3,168 feet. So this, in fact, is 3,168 feet. So now I am going to figure out which trig ratio I'm going to use. This 150 is the opposite side. Just trying to change the color here. and this is the adjacent side. So obviously we're going to use tangent. So tangent of the angle is equal to 150 over 3,168. And the angle is equal to tangent inverse of 150 over 3,168. Putting it into the calculator. And rounding it to, if you want to round it to a whole number, that will be 3 degrees. If you want to round it to a one decimal place, it will be 2.7 degrees. So follow the rounding instructions. And if, like I said before, if no rounding instructions are given and the measurements are in whole numbers, then it's a good idea to round it to one decimal place extra. So since it was actually 0.6, I could do 2.71 degrees, but I rounded it to whole numbers. It doesn't matter. You will not be, the points will not be deducted if none of the rounding instructions are given to you. So at least if you're not matching the rounding of the measurements given in the problems, you can just do one more level of precision, just one decimal place more. Okay, so this is our last problem here. We're given for a climbing wall, a guy wire R is attached 47 feet high on a vertical pole. Added support is provided by another guy wire S attached 40 feet above ground on the same pole. If the wires are attached to the ground 50 feet from the pole, find the angle alpha between the wires. So there are two wires. This is the first one. This is the first one, R, or one of them, R, which is I'm just trying to draw straight lines, which is at a distance of 47 feet from the ground on the building. I'm actually going to use, I need to draw some straight lines. I'll use this feature here. And then there's another wire labeled as S, which is 40 degree from the ground. We need to find an angle between these two, and they label that as alpha. So this would not be a right triangle if I just use this piece. So how I'm going to handle this problem, later on we are going to learn about how to solve oblique triangles, but right now what we only know is the trigonometry. So I need to look at two right triangles. One that is which is formed by the wire R, and that wire R is just trying to change it to my pen. That wire is 47 feet above the ground, and the angle that it is making, we call that angle as beta, and this is 50 degrees, 50 feet. Not thinking when I'm talking. And then there's another triangle, which is made by this other wire, the wire S, and this angle is still 50. This angle, let's call that gamma, because the alpha is the difference between these two angles, right? So we're looking at the angle beta as the whole thing, and then we're calling this as angle gamma. Okay, so we have to identify which trig ratio we're going to use. Again, we have the opposite side and the adjacent side. Here also we have the opposite and adjacent, so we are going to use tangent. Tangent of beta is equal to 47 over 50, and here tangent of gamma is equal to 40 over 50. So if I do tan inverse, then I have beta is equal to tangent inverse of 47 over 50, and gamma is tangent inverse of 40 over 50. Alpha is the difference between beta and gamma. So I'm going to just put them into the calculator. This comes out to be approximately 43.23 degrees, and this comes out to be approximately 38.66 degrees. The difference between the two is about, you can put it all together as well. Like you could put 10 inverse of 47 over 50 minus 10 inverse of 40 over 50 and then round your answer would be actually better. So if I round to one decimal place, then my answer is 4.6 degrees. Okay. I hope you found this helpful. There are many situations like these where we actually look at the figure as two right triangles and then find that missing piece of information. So hope this was helpful. Thank you.